There we go. All right, on the back, real quick, there's the grading scale. Again, it's a weighted system, so you can see how exams are worth 60% of your grade, regardless the point value. Bless you. Bless you. You going for 3? I am totally and completely fascinated by people that can sneeze 3 times in a row, because I've never done it a single day in my life. Okay, I've sneezed twice, but I'm fascinated by people who can sneeze more than 3. I know it's silly, but I am. Okay, so if you do sneeze 3 or more times, you might see me get a little excited, and that's why. For sneezing, we'll see. All right, exam 60, quizzes 30, homework 10, and you can see kind of the topics that we're going to go over this year. So far, so good? Great, perfect. All right, next is your signature sheet. The top part, or the first 2 lines, are for you, just so I know that you are aware that we went over these rules, expectations, policies, all that. I do want you to take the syllabus home and this signature sheet and have a parent or guardian sign it as well, just so that I know they are aware and I don't get a phone call or an email later this year saying that they don't understand why something happened. And I can just refer that they should be familiar with the syllabus and policies and everything, and that's why it is the way it is. Okay, so I need someone from home to sign it. I would like this sheet back tomorrow, okay, but at the very latest next week, just in case someone's not home, okay? So try your best to get that tomorrow. So without further ado, we're going to start our first unit, which is going to be review. Okay, going to be some skills that we've learned and developed over the last few years of our mathematical career. I will be passing out many papers to you this year. There's no book, okay? I like to think that I know you guys. I know we just met, but I like to think that I know you guys better than a publishing company. So what I've done is developed my own material from different books, websites, workbooks, different things to make sure it makes sense for you. Okay, not just using one book as like the Bible. Okay, so there's no book for this class. There's just going to be these notes that I hand out to you. So this is the cover page. You can put this on the front of your binder if you have that sleeve, so you know it's your math binder. The next page is the table of contents. So what I gave to you are all of the papers that you're going to need for this first unit. Okay, I'm going to give you these note guides a unit at a time. Instead of giving you all 400 and some pages at once, which would be very overwhelming, we're just going to do one unit at a time. So what we're basically doing this year is developing our own textbook where you're going to have every single problem available, every single problem worked out, and it's going to be by you. So I think this is going to be a really good reference or resource for you to have after you leave this class. Okay, so this is your textbook that you're developing this year. The next page is the title page for the unit. Okay, Unit 0 at the top. This is going to be a good kind of schedule for you to be aware of. On the left-hand side are how many days I think that each section is going to take us. Usually 2, maybe more, maybe less, depending on how we're doing, but it's usually 2 days. You'll also see under the objectives what the topics are for that particular section. And then on the right-hand side, you'll see the page numbers for the notes, but also the page numbers for the homework. Okay, everything is organized in here. Can we appreciate the organization? I hope you do. I am minorly OCD. I know some of us aren't like that, okay, but I need organization to feel sufficient, we'll say, okay? I can't really stand chaos. You can also use this to help you judge when a test or a quiz is coming up. Those will always be bolded, okay? I'll also be using this board as kind of a weekly schedule. So notice how today on Thursday we're going to start our first section 0.1. Okay, so you can look up there too for scheduling. Are we ready to start?
Yep.
No, but yes?
I guess.
You guess?
Yeah.
All right, let's go ahead and take a look at page 7. Our first section, we're going to talk about functions and getting familiar with our graphing calculator. We'll see how much we get to the calculator today. So function notation, half of the battle, maybe more than half of the battle, in any math class is understanding what the heck am I trying to find, or what the heck does this mean. We need to learn this year how to read math. Okay, it's its own language. It's basically another language course. We got to get familiar with the symbols, the meanings, the representations, all of that. And we have tables, we have graphs, we have equations. There's a lot of things to get used to. So we're going to try to start slow for review and then bring it all together as we go through this first unit or two. So at the top, we have our function f of x, okay, 9 minus 4x. And we got to get used to what these different function notations are representing or asking us to do. So let's just start off with part A. F of negative 3. What do you think that represents? What do you think the negative 3 means? What do you think, Nick? Yeah. You sub negative 3 in for x. Good. This is an input value. That's what you plug into the function for all the variables, in this case x. So 9 minus 4, and then we'll plug in negative 3. Can we simplify? Yeah, order of operations, parentheses, and then multiplication. Negative 4 times negative 3, positive 12. 9 plus 12, 21. What do you think that 21 represents? The answer. Can we use a different word? It is an answer. Solution. If this negative 3 was an x value, 21 is a y value. Okay, so answer, solution, y value. If negative 3 was an input, 21 is a output. Look at all those synonyms. Okay, words for math. We're learning a language. So maybe we'll put output, or you could put any of those other ones we just mentioned. If you know an input and an output, if you know an x value and a y value, can we write the ordered pair that would show up graphically? What would that look like? How do we organize these two thoughts as an ordered pair? The x goes first. Input first, all right, so negative 3. And then the y value or the output, which should be 21. Perfect. Is it coming back to us? Hopefully it never left. Oh, it left. I know it's a short summer, but it's a long summer as well. All right, let's try the next one. F of x equals 10. What does that statement mean? What does the 10 represent? It's a little different notation for this one, so it probably isn't the same process we just did. What do you think, Eli?
I think the 10 represents the output.
Okay. So that's an answer. So where can we put that in our function?
Plug in f(9 minus 4 equals 10).
All right, so 9 minus 4x equals 10. So if we know the answer, maybe we can figure out what the input was, or that x value in this case. Can we solve? Yeah, move the 9. Divide the negative 4. We get negative 1/4. So this must be the input value for the function. And therefore our point, we would need input comma output, x comma y. I think we're good with those. At least I hope I'm assuming correctly. If we step it up a bit though and take a look at C, we have f of h, no more number. What does that mean? What does the h represent? Can we find a pattern between maybe the two that we just did? What might this h represent in terms of x, y, input, output, answer, solution, any of those words? Was that?
Can you give me a hint?
I'll give you a hint. Did we have one already that kind of looked like f of something?
No.
Yeah, where was it? A, f of -3. So what's this h? If it's an input. You can input a number, you can input a variable, you can input a symbol. For instance, if I said f of question mark, that question mark is an input. It's what you're substituting into the function. So if we substitute this h in for that x variable, we'll have 9 minus 4h. Can we simplify?
No.
Why not?
Because we do not have, we don't know what H is.
We don't know what h is. Okay, we don't have like terms. This is a number. This is a coefficient with a variable. This is as far as we can go. Even though we were able to simplify the previous example, because they were all numbers, this one not so much is the case. So this, if it's our final answer, if it's our final solution, must be the output. So what would our point look like? H is the input. 9 minus 4h is the output. Do we realize how it's a very similar problem? Input, output. It's just the difficulty level is a little different. Here, you are used to working with numbers. Here, we're going to get used to variables, okay, stepping it up a bit. But it's a very similar type of problem, okay, same kind of content. Let's try D. What is the x plus 2 representing?
Input.
The input. So in our function, we need to substitute in x plus 2, all of that. Can we simplify?
Yes.
Yeah, maybe distribute. Combine some like terms. Say that's as far as we can go. So what might the ordered pair look like? X plus 2, negative 4x plus 1. We doing okay? Hanging in there? Aside from the heat?
Oh, it is toasty.
Yeah, this is one of the hotter rooms in the building, and it stinks that you guys are here in the afternoon, okay? But depending on the case, some days we might go over to the Audion if it's available, okay? But we'll see about that. All right, so good review, input, output, function notation, but we're also going to get used to this year applying what we are talking about in terms of the mathematical notations and vocabulary. So we're going to take this whole function notation idea that we just did and relate it to some type of word problem or scenario where we actually have meaning behind the numbers that we're using. Almost like in a science class where you have units, okay, the numbers mean something. So let's take a look at our free response question. A free response question is a multiple part question that's all related to the beginning equations or directions at the top. So we're going to try to answer different things about this particular scenario. Johnny enters a 7-day Pokemon tournament. The function below models his total cards over the tournament. Before we even tackle some of the problems, I want you to get used to underlining, highlighting certain things that are important in this problem. For instance, we're talking about cards. It's a Pokemon tournament that is 7 days long. Maybe some good things to get used to or be familiar with. Can we label what the variables represent? It's no longer just X or Y or T in this case. Okay, we actually have meaning or units now behind these variables. What do you think, Eli?
I think C means the cards.
T would be what?
The cards.
Why?
Because total cards that
Okay, so we are definitely talking about cards. That is one of the variables.
well, that's what the input is.
Perhaps. Can we think about what our two variables are? Normally they're x's and y's, but now there's something different. Yes, we're talking about cards. What else are we talking about? A tournament, which is how long? Days. Okay, we're talking about time, t. Maybe that's a little clue, okay? So typically whenever you have a variable of t in there, it's usually representing time. So this variable is representing time in days. And if we input a day, what do you think we're going to get out, Eli?
We're gonna get out
Total cards. There we go. All right, let's check out 1. What does the notation C of 3 mean? And we're actually going to find it. So very similar to the ones we did at the top. I mean, they were F's in that case, but it doesn't matter what letter you call it. What do you think that 3 represents? Yes?
input value.
Input value. All right, so when the tournament is on day 3, we're having an input value of 3 day, or the 3rd day. What do you think C of 3 is then? The total amount of cards. When the tournament is on day 3, C of 3 gives the total amount of cards. Now we have meaning behind the numbers, meaning behind the math. But we're not done yet. They want us to find it. Okay? So we said 3 was a time. Notice how that was our input variable, just like an x is typically. So let's go ahead and plug in 3 for all those t's. Now I know most of us, if not all of us, should be able to simplify that by hand. Yes, it would take some time because you're cubing, you have a little bit of fraction work in there. Okay, I know we can do that by hand, but since most of us are not familiar with a calculator, I want to show you how you would type this in to solve it. Okay, we've got to get used to our fingers and thumbs, muscle memory, typing in some buttons. Okay, so do me a favor and open your calculator. The on button is at the very left-hand bottom corner. We're going to try to type in this equation as it's written on our paper. Now, most of us are probably used to those very thin calculators, is that right? Yeah? We'll do that tomorrow. Is that our first bell, or is that the last one? That's the last one. All right, we'll do that tomorrow. How do you do fractions? We're going to do that tomorrow.